So now that we know what we want to do in this lesson, let's learn some vocabulary and look at a quick example to help us tie in what we have already done, and then we will actually start looking at how to find the probability that an average of some random sample would meet a requirement or not. So our first definition is a sampling distribution of sample means. A sampling distribution of sample means is the probability distribution. I'm going to stop right there. We do know what a probability distribution is. We have seen probability distributions for both discrete and continuous random variables, but it is a probability distribution of sample means. And that should be making a little bit of sense, I hope, because we just had this conversation here about what we're going to be doing in this lesson. We're going to be looking at sample means and then asking questions about those sample means. So it is a probability distribution of sample means that is formed when random samples of size n are repeatedly taken from a population. So again, remember, all these little circles in this diagram here, all these circles represented a random sample. And in my little example, I said that our sample size was 40. So in my example, when I say of size n, you don't have to draw all these arrows on your note sheet. I hope you're not, because that would look pretty messy. But just to give you some perspective, that n is talking about the size of the sample that we're taking from that population. So that is what a sampling distribution of a sample mean is. Now that definition is very hard to wrap your head around. So in this first example, our goal is just to understand what is a sampling distribution of sample means. That's what we're going to look at now in this video. So example 1, we have the number of times 4 people go to a grocery store. 4 people go grocery shopping in a month is either 1, 3, 5, or 7. We are given a probability distribution, a probability histogram rather, for that data. So here's the probability histogram for that data. So we could see that for one person, there is a 25% chance that they will go to for going to the grocery store one time is a 25% chance. Going to the grocery store 3 times is also a 25% chance, 0.25, so on and so forth. And we've seen examples of making those probability histograms. Now let's say that I randomly choose 2 of these 4 people with replacement. The first question, part A, is just asking us to list all of the possible samples. So if I was going to choose 2 people, what are the possible samples that I could end up with? Well, if I pick 2 people, depending on how many times they go to the grocery store, and I am picking with replacement, then I could pick 1 twice. So I could pick, you only went to the grocery store once, and then you also only went to the grocery store once, the second person. Or I could pick someone who went to the grocery store once and someone who went to the grocery store 3 times. Or I could pick someone who went to the grocery store once and someone who went to the grocery store 5 times. Or someone who went once and someone who went 7. So all I'm doing right now is I'm writing all the different ways that I could pick 2 numbers from this set. How many times they went to the grocery store. I could also pick 3 and 1. Or 3 and 3, or 3 and 5, and 3 and 7. 5 and 1, 5 and 3, 5 and 5, 5 and 7, 7 and 1, 7 and 3, 7 and 5, or 7 and 7. Those are all of the possible sample sizes of size 2 if we are picking 2 people with replacement. So I just listed all the different ways we could get 2 people. So we have completed part A. We have listed all those possible samples. B is asking us to calculate the mean of each sample of size 2. I'll talk about that second sentence in a second. So I'm going to go over here and I'm going to calculate these means. So I'm just going to be averaging the 2 numbers that are in my sample. So for example, that first mean, the numbers in my sample were 1 and 1. So I would do 1 plus 1 and I would divide it by 2. We're averaging it. And that would give us an average of 1. I'm just going to jump down here because I want to make sure we understand what's happening here. If I had picked 3 and 5 to get the average number of times that those 2 people went to the grocery store, I would add 3 and 5 and I would divide it by 2 and see, well, on average, both of y'all went to the grocery store 4 times a month. So I'm not going to compute all of these averages live in the recording because I know that we know how to average numbers, but I will go ahead and fill them all in. And please do check that you're getting the same values that I'm getting when you average these numbers together. So I went ahead and I've averaged all of those numbers together. So we have completed the first part of part B. We have calculated the mean of each sample size of size 2. The second part of part B tells us these means form the sampling distribution of the sample means. So that means that if I'm picking 2 people from this list, or from that set right here, how many times they went to the grocery store in a month, the only options that I can get for the average of those 2 people, how many times they went to the grocery store in a month, is one of these numbers. So what we're talking about in this lesson, and we will do this down here in part D, is we're going to construct a probability distribution, but this is a probability distribution for the sample mean. This is a probability distribution for these numbers. So out of the 16 different ways, and I'm getting 16 because if I actually count how many samples of 2 people I could have picked from this, there is 14, 15, 16 of them. So out of the 16 different ways that I could pick 2 people, it is possible that our average was 1, because we did get averages of 1. It's also possible that the average is 2. It's possible that the average was 3, 4. I can see an average of 3. I can see an average of 4. We could have gotten an average of 5. We could have got an average of 6, and we could have gotten an average of 7. So we're going to be working on eventually filling out this probability distribution for, well, what's the probability that the average number of times 2 people went to the grocery store was a certain number, so on or so forth. That's what this means when it says these means form the sampling distribution of the sample means. These averages form the sampling distribution. We haven't filled out the probabilities yet. We haven't talked about that, but that's just completing part B. Part C is asking us to find the mean, variance, and standard deviation of the sample means. So part C is asking us to find the mean, variance, and standard deviation of all of these numbers here. So if I were to average all of those numbers together, what would we get? If I were to find the variance of those numbers, what would we get? If we were to find the standard deviation of those numbers, what would we get? We'll calculate those in a second. And then we're going to compare the answers that we are getting with the mean and the variance and the standard deviation of the original data set. So I want to make sure, before I calculate anything, I want to make sure that we're clear that this mean, this variance, and this standard deviation are just from this original set of data. We then started taking sample sizes of size 2 and then finding those means. That's what we did in the table. Okay, so let's not get those 2 different sets of means confused. So for part C, to find the mean, I need to add up all of these numbers and then divide by 16. So I need to, and you don't necessarily have to write this because I know we know how to average numbers, but I'm adding 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 3, 4, 5, 6. So I'll add 4, I'll add 5, I'll add 6, and I'll add 4, 5, 6 again, and then I'll add 7. And to find the average, I would need to take this, and then I would need to divide that by 16. And when we do that, we see that listen carefully to this, we see that the mean, or the average, of those means is 4. This comes out to give us 4. So we have found the mean of the sample means. Now I will go on to find the variance of the sample means. And then I will also be finding the standard deviation of those sample means. And these I'm not going to calculate on camera because this lesson is not about calculating variance. This lesson is not about calculating standard deviation. Those are descriptive statistics that we've calculated towards the beginning of this course. It might be easier for you to just take all this data right here and put it in Excel and run the summary statistics on that data, just like you did in that first project with the data that you picked, and you went and you calculated the mean and the variance and the standard deviation and the range and the quartiles and so on and so forth. That's the same thing that we're doing here. You should get that your variance for this, for those sample means is 2.5. And you should get that the standard deviation of those sample means is 1.6. So we're being asked to compare that with the mean of the original data, which was 4, and the mean of the variance and the standard deviation of the original data. So what we should notice is that, erase all these circles in here, the mean that we got, the mean of our means was the same thing as the mean of the original data. The mean of the sample means was the same thing as the mean of the original data. We will talk about the notation of this later, but the mean of those sample means is denoted as mu sub x bar. So when we added all these numbers up together and then divided by 16 to find the average of those numbers, that was us finding mu sub x bar. So we can now see that mu sub x bar, the mean of the means, was the same thing as the mean of the original numbers that we started with in the data set. And what's not as obvious, we're not particular. And what's not as obvious is that the standard deviation we have of 1.6 is equal to the original standard deviation of the population, which was the square root of 5 that was given to us, divided by the square root of the sample sizes that we took, which was 2. So what we have just generalized, what we're seeing here, is that the standard deviation of the sample means is equal to the standard deviation of the population, just a regular sigma, divided by the square root of the sample size that you took. And the notation for this, the standard deviation of the sample means, the standard deviation of these numbers, is sigma sub x bar. Sub x bar. And when I say sub, you all, I mean sub, like it should not be in line. So if you turn in anything to me with your handwriting on it, I should not see mu x bar because that's in line. Those are all on the same line. I should see mu sub x bar. The x bar is a subscript. It should be lower than the mu. Kind of like the same way if you were writing x squared, you wouldn't just put the 2 right there. You'd put the 2 as a superscript. Same idea, just a subscript, so it goes lower. Okay, so in part C, what we are gleaning is the relationship between the original mean and then the mean of the sample means, and the relationship between the original standard deviation and then the standard deviation of the sample means. And we will go back and tie that in and look at some more examples of that, but this is just introducing us to some patterns that we will notice as we go through this lesson. Part D is asking us to construct a probability distribution of the sample means. So part D is asking us to fill out this table. This column is all of the possible sample means that showed up here. We're going to then calculate, well, what was the probability that the mean was 1? What was the probability that the mean was 2? What was the probability that the average was 3 when you took a sample size of size 2? That's what we're going to be filling out in part D. So constructing this probability distribution is creating the sample distribution of the sample means. That is what a sampling distribution of sample means is. It is this table. It is this probability distribution. It is a discrete probability distribution in this example. So now let's go ahead and construct this sampling distribution. Well, we knew that in total there was 16 different ways that you could pick 2 points from that data that we had of 1, 3, 5, 7. The only one Only one of those 16 gave us a mean of 1. So there's only a 1 out of 16 chance that the mean will be 1 when you take a sample of size 2. 2 of those, sorry, I'm picking different colors. 2 of those gave us a mean of 2. So there's a 2 out of 16 chance that your mean would come out to be 2. Let's look and see how many of them gave us a mean of 3. Here's one with a mean of 3. There's a second one. There's a third one. So there's a 3 out of 16 chance that your average would have been 3. Let's see how many of them gave us an average of 4. There's 1, there's 2, there's 3, there's 4. There's a 4 out of 16 chance that your average was 4. Let's see how many of those gave us an average of 5. We had 1, 2, 3. 5 show up out of the 16 in total. Let's look and see how many of them gave us an average of 6. We only had 2 of them that gave us an average of 6 out of the 16 in total. And then finally, let's see how many of them gave us an average of 7. Well, it's just this one down here at the bottom that gave us an average of 7. I'm going to go and write these probabilities as decimals, because I'm also going to be creating a probability histogram. So before I even write the decimals, let's talk about what I mean by this probability histogram. I'm going to create a histogram. On my horizontal axis, I'm going to be looking at the options, the possible outcomes for the sample mean. And we have seen that the possible outcomes for the sample mean are either 1, 2, 3, 4, 5, 6, or 7. Those are the only options that we get out for the sample mean. On the vertical axis, I'm going to be graphing, well, what is the probability that your mean was 1? What is the probability that your mean was 2? So on and so forth. So 1 out of 16 is about 0.0625. 2 out of 16 is about 0.125. And I'm going to go ahead and fill out the rest of those, and then we're going to go graph it. So we have our probabilities filled out. I'm going to go ahead and set up my vertical axes. So I'm going to go as high as 0.25, and then I'll just come down by 0.05. So then I'll be at 0.2, and then I would be at 0.15, and then I would be at 0.1, and then down here I would be at 0.05. And I'm going to start graphing these. So for the first one, if the mean, again, and I know I feel like I'm beating a dead horse, but if the mean came out to be 1, there was a 1 in 16 chance of that. So I'm going to go up to about 0.0625 on my histogram. So I'm going to go a little bit above that and end right there. If the mean came out to be 2, there was about a 0.125 chance of that happening. So we're going to go up to, yikes. Oh no, I erased it. We're going to go up to 0.125, so about right there. Halfway between 0.10 and 0.15. And notice how I am trying to center the bars of my histogram around the sample mean that I'm talking about. I should probably make the first one a little bit wider so all of our bars have the same width, because that is a characteristic of a histogram, as we learned back when we learned about graphics. If our mean came out to be 3, there was about a 0.1875 chance of that happening. So I'm going to go up on the 3 and end a little bit before I get to 0.2. If our mean came out to be 4, what we have here in orange, there was a 0.25 chance of that happening. So here we're going all the way up to 0.25. I know my bars aren't equal, but I think y'all get the point. If the mean came out to be 5, if the mean was 5, there was a 3 out of 16 chance of getting that, which is 0.1875. Notice that these are the same. So the height of this rectangle needs to be exactly the same height as that light blue rectangle, going up to 0.1875. And then if the mean came out to be 6, there was a 0.125 chance of getting that. Notice that these are the same. This is what I meant earlier about hopefully you're noticing something about those numbers. So what kind of shape is this? What kind of histogram are we getting here? Let's go ahead and graph that last one. If the mean came out to be 7, there was a very low probability that I picked 2 people and they both averaged out to be going to the grocery store 7 times. That had a 0.0625 probability. So that's down here. And notice that this is the same height as our first rectangle. So what do you notice about the shape of this histogram? It is normal. And remember, a normal histogram is just a symmetric histogram. It is just a bell-curved histogram. And we really, really, really like normal things in statistics, because if something is normal, then you can use the standard normal distribution. You can use z-scores. You can use a bell curve. You can use the empirical rule. And we looked last week in the last few lessons at a lot of different examples where we were then taking something that was normal and then using that to go find probabilities. So this idea that when we find the sample means, it gives us a normal distribution is what this lesson is really based off of. Because it is normal, there's a lot that we can do with it.